Moving on to question 6 now. We're dealing with circles in this question. We're given the information that it has a centre A here with the coordinate 7, 5. So this is this point here, A. We're told the line L with equation y equals 2x plus 1 is the tangent to C, the point P here, as shown in figure 3. For the first part of the question, we have to show that an equation of the line PA, so that's this line here going through here, is 2y plus x is equal to 17. So we have a bit of information, we know what we're aiming for, so let's get there, see if we can get there. So first off, we need to think about gradients. So we're told this is the line with equation y equals 2x plus 1. So y equals 2x plus 1. So if that's 2x plus 1, well, what we need to consider first is what's the perpendicular gradient here. So the gradient here is 2, so the perpendicular gradient, so if I call this perp m, well, that's going to be negative reciprocal, so flip this, I'd get a half and make it negative, so that'd be minus 1 over 2. So the perpendicular gradient is minus a half. So now we know the point it's going through A here, like this. So all we need to know is sub in the coordinates for A here. So that's going to be y minus y1, so that's going to be y minus 5. Because we know this is the y1 point, so y minus 5 is equal to x, or minus a half. Sorry, that's m there, your gradient, m times x minus x1, where x1 is 7. So what we can do now straight away is times 3 by the denominator here of 2, so that's going to give me 2y minus 10. And that's going to be equal to minus 1 times x times minus 7, so that's going to be equal to minus x. And then be careful here, minus 1 times minus 7 is plus 7. So we're pretty close, we've got a 2y, we've got a minus x here, where we're in the positive x, so let's just do a bit of rearranging here. So I've got minus 10, I've got a plus 7 here, we need 17, so we're clearly going to take this minus 10 across. So that means 2y is going to be equal to minus x plus 17, so all we need to do now is take the x across as well. So if we do that all in one swoop, that gives me 2y plus x is equal to 17. Is equal to 17, and there we go, that's the first part done, and we've shown that it does have the equation 2y plus x is equal to 17. So now for part part B then, we have to find an equation for C, so that's where my C came from there, for 4 marks. So C here is the circle that's going around here, and we have to find an equation. So we already know the centre, so we don't need to worry about working out that. All we're going to need to work out is the radius of this circle, right? Now we have two equations. We have this line here, and we have the perpendicular or the normal to it. So how do we now work out the coordinates of P here? Well, if we have two equations and they intersect like this at a right angle, what we can do is make them equal to each other. So this is for part B. What we can say is that y equals 2x plus 1 and 2y plus x is equal to 17, and now we just need to solve this simultaneously. So this allows us to work out the coordinates of P. We already know the coordinates of A, and then we can just use, Pythagoras to work out the remaining length here, or the distance formula, should I say. So that's 17. So what I can do here is make x equal to 17 minus 2y. X equals 17 minus 2y. And I'm going to sub it into this equation now, putting it back into equation 1. Y is going to be equal to 2 lots of this. So 2 lots of 17 minus 2y plus 1. So that's going to give me 34 minus 4y plus 1 at the end. And that's y equals. So if we simplify this now, this minus 4y will go on to this side, so that gives me 5y. And 34 plus 1 is 35. So y is going to be 35 divided by 5, so therefore the y coordinate will be 7. And now we can simply work out the x coordinate. If we make 7 equal to 2x plus 1, we take 1 off, so 2x is equal to 6, and then to work out x we divide by 2, so therefore x will be equal to 3. just subbing the 7 back into this equation. So 7 is equal to 2x plus 1 and solving that. So we've got the coordinates of P, and that's 3, 7. All we need to do now is just use distance. So if we do it over here, PA is going to be equal to the square root of 3 minus 7 squared. So we're going to be doing the x coordinates, subtract it and then square it, and then same with the y. So that's going to be plus 7 minus 5 squared. And what's this going to give me? That's going to give me 4 squared, so that's 16. 16. And that'll be 7 minus 5, so 2, square that, plus 4. So we simplify that, that's the square root of 20. So that gives us the square root of 20. So that's r. So remember, when we write the equation of a circle, it's x squared plus y squared is equal to r squared. So this is r now, this is my radius. So the equation, so if we do it over here, equation, I'll just do it down here so you can see. So my equation now, so we know the coordinates of the centre here, it's 7, 5. So remember, we do the opposite sign. So because this is plus 7, this is plus 5, it's going to be x minus 7, all squared, plus y minus again. That's a 5 because it's 5 here. So y minus 5 all squared. And this is going to be equal to r squared. So if r is the square root of 20, that means that's going to equal to root 20 times root 20, which is just 20. So that's part B done. So let's quickly rub this out now, and let's get on with part C here. So we'll quickly rub this out. So just be sure to go back if you miss any of this, guys, or you need to copy it down or anything like that. So part C, it's actually pretty quick for 3 marks. What we need to consider here now is that we're told that the line with equation y equals 2x plus k, where k is not equal to 1, is a tangent to C. So let's think about what's going on graphically here. So this is the line y equals 2x plus 1, and we're told the line with equation y equals 2x plus k is also a tangent. So that means these lines are parallel, right? They share the same gradient. Now if they share the same gradient, what we need to consider is where this tangent is going to be. So the only other place this tangent could be, if these are parallel, it's going to be down here. Imagine you can pick this line up, pick it up, and we can drop it here. So it's going to look something like this, right? I know that's not an actual perfect tangent, but that's what it's roughly going to look like. So we need to consider what the coordinates of this point here would be where it's touching. So we call that point M there. What's the coordinates of M going to be? Well, how do we work that out? Well, what you need to consider is how we get from P to A, and then how we get from A to M. So this is a radius from P to A, like that, and it would be the same from A to M, like that. So how did we get from P to A? Well, P is 3, 7, so P, let's just change that to Y. P is 3, 7, and A is 7, 5. So how did we get from P to A? Well, we added 4 to the x coordinates, so plus 4, and we subtracted 2 in the y's. So if we do that from A now, if we add 4, so M, it's going to be 7 plus 4, so that's going to be 11, and then 5 minus 2 gives me 3. So them are the coordinates of M, 11 and 3. Now what we need to do is just sub this into this line that we've got here. So y is equal to 2x plus k, so y is 3, so 3 is equal to 2x, so 11 times 2, so 22, plus k. So therefore k is equal to 3 minus 22, which is equal to minus 19. And there we have it, that's the full question done.